Okay, we're beginning lesson 40. We are talking about the quotient rule for exponents. Basically, that means what do you do with your exponents when you're dividing? Because quotient is the answer to a division problem. Okay, so we have this example here, x sixth over x to the fourth. Well, what you do is you subtract the exponents. When you multiply, you're adding the exponents, but when you divide, you're subtracting. So this is basically like saying x to the sixth minus 4. Okay, so you're subtracting your exponents, so the answer is x squared. Okay, now sometimes they will ask you to write your exponents in the numerator, which is what we have here, or they'll say, actually, could you write the answer with the exponents in the denominator? Well, how do we take x squared and put it in the denominator? Well, if you remember, what you do is once you move exponents from the top or the bottom, from the bottom to the top or from the top to the bottom, you have to change the sign in front of your exponents. So here it was x to the positive 2, now it's x to the negative 2, and you have to flip it like the reciprocal, okay? So this could have also been your answer depending on what they said. This is your answer if they said, hey, keep your exponents in the numerator. Or they would have said, hey, keep your exponents in the denominator, and this would have been your answer. These are actually the same number, even though they look very different. The answer will be the same when you solve for them. Okay, a couple more examples. We have x to the 6 over x to the negative 4. So remember, we're taking this top number and we're subtracting our bottom exponent. So you have a 6 minus a negative 4. Two negatives together is a positive. This becomes x to the 10th. Not too shabby, okay? This number down here, these down here, are x to the negative a over x to the b. Okay, so we are going to write it just like we do anything else. Negative a minus b. You can't simplify that any more than what you've got. But let's say they wanted you to write it in the denominator. Well, then all of these that are negative are going to become positive, okay? So if this would have been x to the negative a plus b, then when you switched it, it would have been 1 over a minus b. Okay, so these signs have to change when you go from numerator to denominator and vice versa, from denominator to numerator. Okay, so remember, when you flip, the signs of your exponents have to change. Make sure that you're reading the instructions and your questions to see, do they want the exponents in the numerator? Do they want the exponents in the denominator? Because it's going to change what your answer looks like. Okay, here's a practice question from page 163. This is letter A. And x to the negative 6, y to the 4th, z to the 5th, all divided by x to the negative 6, y to the 5th, z squared. Okay? You have to keep your bases the same, okay? That means that you have to take x to the negative 6 and x to the negative 6 here, and you can't do x to the negative 6 and y to the 5th. You can't combine different variables, okay? The base, your variable base, has to be the same if you're going to divide them by each other, okay? So this is basically x to the negative 6 minus negative 6, and y to the 4th minus 5, and z 5 minus 2. Okay, it says write all the answers with variables in the numerator. Okay, that will make things easier. Okay, negative 6 minus a negative 6. This is plus. So this is actually x to the 0 power, which is 1. You remember that? Okay, y to the 4 minus 5 power. 4 minus 5 is negative 1. So this is y to the negative 1 power, and z cubed, 5 minus 2 is that. So instead of putting 1 here, because I already know it's 1, I'm just going to keep this as y to the negative 1, z cubed. Okay, this is your answer. Now, just because this x was here, it's not like you made it disappear. There is an assumption that this is 1 times this. Okay, I just don't need to write a 1 there because it doesn't matter if I take 1 times this, it's still going to be y to the negative 1 z cubed. Okay, so this is kind of how you work through this. I'm going to do one more example. Okay, here we are with practice question B. M to the 4th p cubed, z to the 10th d all over m to the negative 2, p to the 4th z to the negative 6, d to the negative 2. All right, and we need to simplify that. So remember, when we divide our exponents, they get subtracted. P3 minus 4, z 10 minus negative 6, and d is 1 minus negative 2. Okay. So hopefully you guys can see where I'm pulling these numbers. 4 minus our negative 2, 3 minus 4, 10 minus negative 6, 1 minus negative 2. Okay, our variables down here stay the same. And now we just need to simplify. This is m to the 6th. 4 minus a negative 2, those become plus. 3 minus 4, different signs, subtract. 4 minus 3 is 1. It's negative. Z, 10 minus negative 6, that becomes positive, that becomes 16. And D, 1 minus negative 2 is plus. And so that would be 3. This is our answer because they wanted everything in the numerator. All right, so one more thing to finish out the lesson. This is the distribution property again, but we're throwing in some negative exponents to kind of see, can we still solve when we have those scary looking negative exponents in it. Okay, so the same process happens where we take this outside term, we take it times the first term, and then we take it times the second term. Okay, so we have z to the negative 3 times x to the 4th all over m times m squared. Okay, that's this right here. Then we have 3 z to the negative 3 z over, put a times there, I guess, m times m. Okay, so now we need to figure out how can we simplify this. All right, so we have z to the negative 3. Okay, so we've distributed things through. Let's simplify our answers. And remember, the instruction said to move all of your exponents into the numerator. So we need to make sure that we do that. So we have z to the negative 3, x to the 4th. You can't simplify that. There's nothing that's the same. So z to the negative 3, x to the 4th, all over m cubed. If you see, this is m to the 1st, m squared. When you multiply those together, you add your exponents. That's what m cubed is. Okay, then we have a negative 3z and a 1 for our z here. And when you add those together, negative 3 plus 1 is negative 2. So we're going to have a 3z to the negative 2. And we've got m1 times m1. That's m squared because we add our exponents. All right, let's move all of our m's down here because they're in the denominator up. So remember, when we do that, we're going to switch the sign in front of our exponent. So if this had been a negative 3 here, we would have made it positive. If this would have been a negative 2, when we move it up, we're going to go positive. But right now they're positive, so we're going to move them up and they're going to become negative. So this is what your final answer is going to look like. Z to the negative 3, x to the 4th, m to the negative 3, minus 3, z to the negative 2, m to the negative 2. Let me write that a little bit better so it doesn't look the same as everything else. Okay, so Here it is, z to the negative 3, x to the 4th, m to the negative 3, minus 3, z to the negative 2, m to the negative 2. That's the final answer. Okay, let's go through one last example in this lesson 40. This is example D, practice problem, page 163. Okay, we are distributing m to the negative 2 over 3cm through this parentheses, okay? So just because they started putting this off here in the back, it doesn't matter if it's in the back side or the front side, it still means you have to distribute this through times each one. So you can either leave it here and say, okay, well, I'll take this times this first, and then I'll take this times this for a second, or you could just say, okay, well, it makes a whole lot more sense if I do it like all of the other ones are kind of written down, so I'm gonna just move that whole thing over here, because remember, it doesn't matter if you take 5 times 7 or 7 times 5, you're going to get the same answer. So it doesn't matter if this is in the front and this is second, or vice versa, you're going to get the same answer when you multiply things through, okay? So we're going to take m to the negative 2 over 3cm, and we're going to distribute it through. Okay, so m to the negative 2 times m to the negative 5. Those are two negatives, so we add them together, same sign, and we keep the sign, so that's m to the negative 7th. I'm just going to go ahead and simplify that right now. And then we've got 3cmw for x. None of these x variables are the same. So we're just going to be left with 3cmw to the 4th x. Okay, and then minus, okay, so this is going to go through here, m to the negative 2 cw squared. None of those were the same, so we don't have anything that we needed to add, no exponents that we needed to add. Here we've got an m and an m, so we're going to add those. So 3cm squared x cubed, okay? All right, now let's move all of our stuff up to the, well, at least all of our exponents up to the top, because that's what they want. They want all variables in the numerator, so we're gonna push those up to the top, okay? So this is gonna become m to the negative 7, c to the negative 1, m to the negative 1, w to the negative 4, x to the negative 1, okay? So again, remember, we're moving them up to the numerator, and you have to change the sign when you do that. So I kept this here because it was already from the numerator, and then all of these that I moved up became the opposite of what they were. And guess what we have on the bottom? We have a 3, okay? And now over here, we have m to the negative 2 cw squared, and we're going to move all of these up, c to the negative 1, m to the negative 2, x to the negative 3, okay? And that's all over 3. Okay, so I know it looks like a lot of numbers, really confusing. It's not. We're going to simplify as much as we can. So we're looking for the same kinds of variables. And we have an m and an m. Okay, so we are going to add those together. A negative 7 plus a negative 1, they are both the same sign, so we add them together and we keep the negative sign. So this becomes m to the negative 8. And then all of these stay like that. Let me make sure I didn't miss anything. Okay. And this is an 8. It doesn't look like an 8, but it is. And subtract. Okay, so here we have m's that are the same and then c's that are the same. Okay. So we've got m to the negative 2, m to the negative 2. We're adding those together. Negative 2 plus negative 2 is negative 4. We've got a 1 and a negative 1. 1 plus negative 1 is c to the 0 power. Okay, remember what c to the 0 is? Anytime that you have c to the 0, it becomes 1. So we might as well just erase that, because 1 times anything is that number. Okay, so it goes away. Kind of like cancels out, okay? All right, and so we still have our w squared, and we still have our x to the negative 3. So I believe this crazy little fraction here is what the answer is that we're looking for.